Hello students, we're going to look at the solution now to a couple of practice problems dealing with the difference of two squares and greatest common factors. They're found on page 96 in chapter 7 of book 3 of your Math 1025 booklets. Now these, even in the instructions, it tells you right up front to remove any common factors first. But that's the rule of all factoring. So for all factoring, doesn't matter what type you're doing, okay? The first rule is remove any GCF, okay? So anytime you're doing any factoring, always look for a GCF, okay? And if there is a greatest common factor, then take it out. So take out any common factors, okay? Always. Doesn't matter the type of factoring. So let's have a look. What do we got? I see 50 and 8, definitely something common there. 2 at least is common because they're both even. This one has an A in it. There's an A in this one as well, so I can take out 2A. And this one has x cubed in it. This one has x. And when it comes to variables, you take the lowest exponent. So I can take an x out. Alright? So it looks like I can remove 2AX. So let's do that and see what we got left. 2AX. Now don't drop the common factor. Don't throw it out. Leave it in front. Alright, so what am I left with? Now 50 divided by 2 leaves me with 25. A divided by 8. Now again, when you're taking out a GCF, I see some people do this, and it's not a bad idea. Some people take their common factor and just write it below each one, because factoring out something is dividing by it, right? So they'll write below each one, they'll write it just so they can see the cancellation better, right? So as you can see, I have 50 divided by 2, which leaves me, that's how I got the 25, right? Then I have A over A, which will cancel. Then x cubed over x to the 1 leaves me with x squared. So visually it helps you sometimes if you just put it, right, the common factor under each one. 8 divided by 2 is 4, and the a's cancel. Alright, therefore, okay, therefore, of course, that's all I can do with that, right? I'm done. Now, once you take out a factor in any type of factoring, then you have to check and see if this is factorable. Is what left here factorable? Okay? So, and the answer to this is, of course, yes, because it's what we call the difference of two squares. You should recognize it. So this number here, you just always leave your common factor out front like that. Just leave it. Rewrite it each time you do something. Now, I see 25x squared subtract 4. 25x squared subtract 4. Look at that. We have the difference, and we have a perfect square here. This is the same as 2 squared. I got a perfect square here, same as 5x all squared, and a minus in the middle. So this is, again, the difference of two squares. And we just finished that in the previous video. So if you're not sure of the difference of two squares, go back and watch the previous video. And that gives us 5x subtract 2 and 5x plus 2, right? Because the difference of squares follows this pattern. Remember, a squared minus b squared. If you have two perfect squares, you put the factor for each one, and you put plus in one, minus in the other factor, and the order of plus and minus makes no difference. So that's a pattern type factoring called the difference of two squares. So there's your final answer for that one. Okay? So remove the common factor and then check and see what's left over factorable. And that indeed it is. So there's the final answer. Okay, F, have a look. What do you see common in F? 125 and 5. So you know it's both divisible by 5. So 5 is common. And p to the 4 and p squared. Now take the lower, when they're variables, take the lower exponent. So p squared is common. So 5p squared is the common factor. Now, again, what would you get? 125 divided by 5 leaves me with 25. P to the power of 4 divided by p squared leaves me with p squared. 5p squared divided by 5p squared leaves you with 1. And remember now, 1 is still, okay, a common or a perfect square, right? Oops, let me just move that over. Oh, there we go. Okay, now have a look at the rest of it. We know that stays right there, 5p squared. But look at the rest of it right there. Now, do you recognize that? And you should recognize it as the difference, which means subtract, of two perfect squares. That's a perfect square. That's a perfect square. Okay, so the perfect square for 25p squared is 5p all squared. 1, of course, is the same as 1 squared. Mine is in the middle. So again, it follows that pattern. So 5p subtract 1 or plus 1, doesn't matter which one goes minus, as long as one factor is minus, one factor is plus. So there's the answer to F. Okay, so there's a couple of examples of removing a common factor first, then factoring by the difference of two squares. Hopefully that helps. That's it for now.